So, for number 9, the points are negative 1, 2, 5, 6, and 5. No, that's what we did in class. 10 was 0, 4, and 3, 10, and 4, negative 2, and 6, 0, 4, 0, 4. Try again. 0, 4, 3, 10, and 6, negative 2. So 3, 10, and 6, negative 2. Negative 3, 4, 5, 6, 6, negative 2. Those are my vertices. We want to draw that in. We want to draw in our triangle. Okay. Now to find the centroid, we're going to have to find the midpoints of sides and connect the midpoint with the opposite vertex. So to find the midpoint of this side, again, it'd be 0 plus 6 over 2, 4 plus negative 2 over 2. So that's 3, and 4 plus negative is 2, 1. 3, 1 is the midpoint. And we're going to have to connect. Fortunately for us, that comes right down there. It's vertical. Nice and easy. Next, I need the midpoint of this side. That would be 0 plus 3 over 2, 4 plus 10 over 2. So it's 1.5, 7. Right there. And again, we connect carefully as we can. Finally, the third one is 3 plus 6 over 2, 10 plus negative 2 over 2. So that's 9 halves, 4.5, 3, 4, 4.5, and 4. 1, 2, 3, 4. There is my centroid right there is at 3, 4. There it is. But that's what it takes. We got to find those midpoints and graph them in, graph the line. I can tell pretty easily it's a centroid too because this is my vertical one right here. This is 1, 2, 3, and this is 1, 2, or 1, 2, 3, 4, 5. No, it should be 2.5. I'm sorry, 2.5 because a half. 2.5 and 5, and for those distances, so it works out. So there we are. That's how that works. 39 was the other one you wanted to see. 30 whatever. 35. It gives us a centroid, and then find the value of x. Say 35. AD is 5x, and DE is 3x minus 2. What's the relationship between AD and DE? Which one is longer than the other? We did this in class. Okay, you're not going to know it if you don't even have your book open. Right now I'm looking right now. Most people are looking and they don't even have a book out. So yeah, of course you're going to know. If you want me to help with the problem, you should probably take out your book. So you know what the problem is? It tells us that D is a centroid. So that means that those are medians. Because the only way to get a centroid is if we have medians. So AD and DE, what's the relationship between AD and DE in that picture for 35? It's on page 323. Are they congruent? What's the relationship? Yeah. Which one's half? Or 35. We're doing 35. The value of x, but we need to know the relationship between AD and DE before we can start. Yeah. D is half of AD. Or if you want to put it the other way, if you double DE, we get AD, right? Because I'd rather multiply by 2 than 1 half. Well, you're right. Your statement is right. So if I multiply DE by 2, 3x minus 2 times 2 is 5x. So 6x minus 4 is 5x. Subtract the 6x. So I get negative x is negative 4. So x is 4. That's all it takes. But again, that's well, because we were told, and again, this is a rough drawing, but in this case, you were told that this is 5x, and this is a centroid, and this is 3x minus 2. You said that this is half of that. 3x minus 2 is half of that. So if I double this, it'll be the same as that. That's how I got that equation. But that's what a centroid does, and that's the big mathematical thing that goes on with centroids, is it creates that 2-to-1 ratio. That from the centroid to the midpoint is half as much as from the centroid to the vertex. That's what a centroid does. And the other problems were pretty much the same way. It was GD and DC and DD and BF. DD and BF was a little bit trickier because that's the 2/3 thing. BD is 2/3 times BF, and you get x equals 5/2. So that's a little bit trickier. Because the long part is 2/3 of the whole thing. But that's a relationship. That's what we'll start talking about yesterday. Other questions? So this section of Unit A covered angle bisectors and medians, and very little bit altitudes. Mainly angle bisectors and medians. So let's kind of review what we know. Angle bisectors. Draw one very quick. There's an angle. That is the angle bisector. What do we know about angle bisectors? Someone tell me something we know about angle bisectors. They are in the middle of an angle. They divide the angle equally into two small angles, right? That's definition. Two congruent angles. Actually, they aren't just in the middle. They are exactly in the middle. What else? What do we know about points on an angle bisector? I put a point out here in the angle bisector. What do I know about that point? Yeah. Okay. It does, but what was the big theorem we had here? We did all the sketch pad talk about. What was I telling you? Remember on last Tuesday we did the big sketch pad thing. What was significant about any point on the angle bisector? Any point on the angle bisector our big word? Equidistant. From the sides, yeah. Right angle distance, they're equal distance. What's the point of concurrency called in a triangle for angle bisector? It's called the incenter. So if I do all the angle bisectors of the triangle, it's the incenter, which means the circle is inscribed within the triangle. All right? That's what we know about angle bisectors. So, based on this picture, can I conclude that BD is an angle bisector? Why not? I can't hear you. Okay, it's not indicating angles are congruent. That's one problem. What else? What if I did this? Now, is it an angle bisector? Now, is BD an angle bisector? Yes or no?
Yes.
Why? Because BD is equidistant from both sides of the angle. And any point equidistant from both sides must be on the angle bisector. So if I know this, that means that these must be congruent angles. Okay? But without that, no. I don't know if these two distances are congruent. I know they're both right angles, but I don't know if they're congruent or not. So an angle bisector is equidistant from the sides. It has to be a right angle. What if I didn't have the right angle? What if I took this away, but I did give you this? No. Okay. Again, it has to be the right angle distance. So all sorts of different things we can deal with. So what if I said, based on the information, set up and solve an equation if possible, otherwise, say not enough information. Solve for x. Or if there's not enough information, say not enough information. Is there enough information? Yes, there is. So what I say? Yeah. There's enough information to make this conclusion because they are equidistant. So x is 10, making this both angles 30 degrees. All right. What do we call this point? These are the red lines indicate angle bisectors. All right, so that's an angle bisector. That's an angle bisector. That's an angle bisector. What do we call this point here in the center? The incenter. Okay. And what's true about the yellow lines? They're congruent. The yellow lines are the ones that are congruent. So this has to be the same. So if I drew a circle here, this is not a very good circle. I'm not a good drawer. Looks like he's got some hair, a couple eyes, a mouth, kind of a nose, some face. Yeah, kind of. Maybe he's just got a part, the hair's kind of comes off like that. Little goatee there. He doesn't have ears. There you go. But those are congruent. So we could easily ask questions then based on this. Given that those are angle bisectors, I could say, okay, if this is 23, find the value of x right there. 23. Okay. So we can set things up like that. Any relation between x and this distance here? Nope. That only applies to centroids. All right? That only applies to centroids. This is not a centroid. This is an incentroid. No length relationships like that. Just the equidistant from the side. How about some properties of medians? A median connects what two pieces in a triangle? Connects what in a triangle? How do we draw a median in a triangle? We connect a blank to a blank. Yes. Connects the midpoint to vertex. To the opposite vertex, actually. Okay. What's the point of concurrency called? We call that point of concurrency for the medians. From yesterday. Not an android, but a centroid. There we go. Okay. We know that is the balance point. But more importantly, we know it divides the centroid divides the median proportionally. 2 to 1. So triangle, median, call that the centroid. That means for every unit of x here, there's 2x here. That's what centroids do. D, E, and F are midpoints of the side, so what do I call point G? The centroid. And BF, I would call that a median. What if I said that FG is 12? How long would GB have to be? 24. What if I said that CG is 5x and DG is 3x plus 12. No, hold on. 2x plus 12. Sorry, I gotta make it work. What if I said that? How do we set up that equation? 2x plus 12 equals what? But they aren't equal, are they? One of them is twice as much as the other one. Which one do I have to double? The shorter one, of course. Double the shorter one. We wouldn't double the longer one. That wouldn't make sense. So 4x plus 24 is 5x. Subtract 4x. And we just get 1x equals 24. From there, we could find the length. 5 times 24 would be 100. They're both 100, or 120 and 60. 5 times 24 is 120. 2 times 224 is 48. Plus 12 is 60. It works out. What if I said, and now this is not drawn to scale necessarily, AE equals 60. How long is AG? AE is the whole thing, the whole median. Okay, so I divide that by 3, which would be what? 20. Which part gets 20 and which one gets 40? Okay, the AG gets the 40 and the 40 20. All right, because that's how that divides it out proportionally. YN bisect angle XYZ. Despite appearances to the contrary. Let's see if I can fix it a little bit so it actually looks like a bisect. Let's go there. There we go. YN bisects angle XYZ. So, put points here at X and Z. Does that mean this is N? Does that mean that NX is congruent to NZ? Yes or no? Yes. Why? Because any point is equidistant from the side. So how do we measure distance to the side? We have to have a right angle with the side. Is this the right angle? Is this the right angle? So the answer here would be no. There's not enough information to make that conclusion. Now, if I drew in segments that were perpendicular to the sides, whoops, that one not so much. Undo. Perpendicular to the side. Those two segments, and A will be congruent to NB. Those would be congruent because those are right angle distances. This is not true because this is not right angle distance. You're just equidistant at any 2 points on the side. Equidistant means right angle with the side. Got to have that right angle. Before we can conclude equidistant. I think that's it. Those are the main concepts that we're dealing with on this benchmark tomorrow. And those are the ones you need to be comfortable with. And I have a review sheet for you to help you work with that. You lucky people. Yes. Yes.